Hello, hello. Welcome everyone to Piano Tech Radio Hour. Good to see you here yet again. Hope you had a lovely Thanksgiving a couple weeks ago. Looking forward to a nice Christmas. This is usually when things start cooking up for business. So hopefully everybody's pocketbooks are fattening up a little bit during this holiday season and seeing a little bit more activity. Hopefully you're not getting too stressed out there tuning pianos and running around trying to make sure everyone's taken care of. We are just on the heels of our tuning pin symposium session with Larry Lobel. And it looks like what we'll probably do, he's not joined yet, so we'll have to make sure he gets on here. But once he's going to be able to join, and we're going to continue the conversation a little bit from what he was talking about. He held a tuning symposium of sorts for us, but he had also held a tuning symposium of sorts for sort of his friends and colleagues at one point. He kind of took us through the process of checking out tuning pin tightness on pianos and looking for patterns and trying to understand what the possibilities are for improving some of the issues we have there. And he got to most of his presentation, but we might be able to spill out a little bit into this public forum here of Piano Tech Radio Hour. I'm going to do an intro to the session before we get rolling, and then we'll get moving in on the general presentation. So first of all, let me see here. Let me change the view here. Let me spotlight my video here. And yeah, for those of you out on Facebook and YouTube, welcome to this session. If you're not familiar, this is Piano Tech Radio Hour. And what we do here is we gather every Saturday to meet with and learn from the most fascinating and knowledgeable folks in the piano world, including manufacturers, rebuilders, musicians, makers of other instruments, and of course, piano techs. Our mutual goal is to become better at our craft, helping each other, and to create an ever more musical world together. Piano Tech Radio Hour is brought to you by Piano Technicians Masterclasses, an online learning resource that brings you cutting-edge instruction from piano industry masters without leaving your home. You can find out more at pianotechniciansmasterclass.com. And a new feature that we have here, you can check out old sessions of Piano Tech Radio Hour via our podcast. And you can reach our podcast at pianotechradio.com. You can go and subscribe there. And I'm going to share a link in the chat so that you know how to do that. And I feel somebody's just unmuted themselves. Who is that? If you're unmuted, did you want to speak about something or you just happen to be unmuted? I think it's Jim Kelly. Jim Kelly, do you have something to say? I'm going to mute you if not. Muted. Okay. All right, let me get you muted. Okay, awesome. Now I'll put in the chat for Piano Tech Radio Hour podcast. So we have about we've hit about 3 or 4 episodes out now. So what we're doing is we're going back in the archives and we're releasing this content as podcast episodes, audio only. Of course, if you want to access the video, you can go to Piano Technicians Masterclass. If you're a Radio Hour subscriber, you always have access to the past video recordings. But we wanted to make this accessible, and it just seemed like such an obvious idea. We're all driving around in our cars or we're working in the shop. And it's fun to have something to listen to that's, educational or on topic of what we care about. So yeah, go head on over there to pianotechradio.com. And there's a subscribe page where it will show you all the places you can subscribe: iTunes, Spotify, and all of your podcast player of choice. If you do have a podcast player that you don't see it on, then let me know and I'll make sure it gets added. All right, so let's jump into the conversation here. First of all, I'd like to check in with Larry. So Larry, I think you arrived. So hello, Larry. Good to see you here. I also want to check in with Christopher Storch. So we're talking about tuning pins and tuning pianos and tuning pin tightness. And part of Larry's presentation actually ended up exploring sort of different methods and methodologies for piano tuning pin concepts. And Christopher Storch just kind of explored the idea of screw stringer actions, and he was part of the conversation. Christopher, would you like to be part of the conversation today, or not to put you on the spot, but would you like to participate? Would you like us to explore some of what you've shared?
It's a big topic. Can you hear me?
Yep, you're there.
It's a big topic, and I don't want to take over what you already had planned. I can answer questions as they come up from my experience and my point of view.
Okay.
Yeah, I have in mind to put together, a PTG presentation for a conference or something. There was a question about how to restring them and cutting the string length and all that, but there requires a lot of time to explain. So maybe not anything in depth, but I can certainly answer questions.
Sure. Yeah. I mean, one of the things I was thinking is if you do have some videos on YouTube, we could share them if they're useful. I don't even know. Larry's seen them, I haven't, but we could certainly, with your permission, share them as part of the conversation or not, whatever works.
Yeah, you're welcome to.
Okay, great. I'll leave it up to Larry since he's seen them and he'll know, what might be useful to check in on. So at this point, hey, Carl, how's it going? Good to see you there. At this point, I'll spotlight Larry again because we're basically what we did was just finished this masterclass, basically a study on piano tuning pins by Larry Lobel. And, we were still on discussion topics or a few videos that he had recorded that we hadn't been able to share, a few topics that maybe he could cover or talk about. Also, I'll hand it over to Larry or switch over to sort of speaking with you, Larry. What do you think would be a good place to go next in terms of talking? Would you like to show some of those videos? Any thoughts?
Well, why don't I give a very brief summary of what my presentation was about? Yeah. Start with that. So I've been bugged for all of my career by pianos with tuning pins that are so tight that it makes it very difficult to do a good tuning on the piano. And after many years, I decided to investigate it in a more thorough way. And I organized a tuning pin symposium among my chapter members. And we gathered at where I'm employed at Sonoma State University as the technician, and we took samples of tuning pin tightness or torque on all the pianos there. And we gathered that data, and I used that data and some other things that came out of the symposium to write a couple of articles about the subject that were published in the PTG Journal in 2020. And I had interesting responses from that. It seems to have aroused some passions in the piano tech industry that other people shared my frustration with the difficulty of tuning pianos with tight tuning pins. And then I decided to put together this masterclass that I just did for Ethan's group. And I learned a tremendous amount of really interesting, fascinating stuff, which is not known to technicians of today from the past. The most interesting of which is that there have been many tuning systems without a wooden pin block in the past that were used on many different brands of pianos, including well-known successful makers like Mason and Hamlin with their screw stringer. Most of us have heard of that, but there was also Ivers and Pond had a tuning pin system without a wooden pin block. Wurlitzer did. And then lesser known makers like Wegman and Baker. There were quite a few. So there's been an ongoing effort over many years that started in the late 19th century and extended well into the 20th century to introduce pianos to the market that did not rely on a wooden pin block. And there were many different systems designed, and I studied patents that were filed for many different ideas about how to do this. There's all kinds of variations and possibilities. Very clever. Some of them were never tried, and some of them were put into production and remained successfully in production for 20, 30, 40, 50 years. So it was fascinating to learn this, and it got me to a point where I want to share this information with my contemporary piano technicians and see if we can have an influence on manufacturers and individual piano builders to try out something like this. It's an idea that was very compelling in the early 20th century, worked on by many people, and then it seems to have died out. And even though there's lots of innovation going on in our industry now, all kinds of different things being tried on pianos, that's one area that no one has touched for 100 years. And I would like to change that. So
there's a revolution a coming.
Yeah, I hope so.
Yeah, cool. So what do you think? What do you think is the next place? Some of the videos, or continue with some of the conversation we had to cut off just for everybody else's info?
Yeah, let's go to some of the videos.
Okay.
So let's start at the end. If you could show my video number 11 first,
Okay.
Ethan.
Yeah, let me find that. So,
And this is a video that it's a portion of a factory tour of the Fazioli factory. I just took it offline. It's readily available for anyone to look at. But it shows something really fascinating, which people may not be paying enough attention to.
All right, we ready for it?
Don't start it just yet. I want to give a little intro.
Sure, go for it.
We have a Fazioli concert grand at the concert hall where I tune. So I've been tuning it for many years. It has tight tuning pins. They're not ridiculously tight. They don't snap, but they're very tight. But yet, in spite of that, this piano is a joy to tune. It's very easy to tune, and I love tuning it. And that's because every tuning pin feels exactly the same. The consistency from one to the next is unsurpassed, and I don't find that on any other pianos that I tune. And it's been bugging me, wondering, how do they do that? How do they get that absolute consistency on every single pin, which no other manufacturer seems to do? Yamaha sometimes has it. They get close. Many Yamahas are easy to tune, and I think the consistency is a large part of that. But most pianos that we tune, they don't have that. So when I looked at this portion of the Fazioli factory tour, I think I found some of the answers to that. So you can start it now, Ethan. Will I be able to talk and be heard?
The machine first drills the pin block before inserting the.
Okay, now look, there are pilot holes drilled in all of those first, and now they're going back and doing a second drilling with a larger pin. That's important. That's crucial.
The machine slowly inserts the tuning pin into the pin block. This is done with great pressure and precision in order to ensure the holes remain perfectly round.
Okay, great. Now, there are several points to notice about that. In the first shot, you see they're about to insert a tuning pin into a hole with the machine. All the other, all the tuning pin holes in the plate have already been drilled, but they are re-drilling each hole before they insert the tuning pin. So what they're doing is they're drilling a small pilot hole first that's smaller than the tuning pin. Then they come back and they drill a second time in the same hole with a larger pin that is the ultimate size chosen to match the tuning pin. Now, that's a method that was actually advocated by Ron Nossaman for rebuilders to use, and it ensures much more accuracy in having the hole be perfectly sized to the tuning pin, and in avoiding scorching of the wood, regardless of whether the drill bit is hot or not. It avoids a lot of the problems and inconsistencies that come up when you're drilling a hole and installing tuning pins. So, and I looked at other factory videos, and they don't all do it that way. They don't all have pilot holes drilled first. And I think it's a very important component to the consistency that they get. Now, secondly, I don't know if you heard the lady narrating the video. She said, the tuning pins are installed under great pressure to ensure that the holes don't get enlarged. So you'll notice that as they're inserting the tuning pin into the hole, there's several things going on at once. For one thing, the tuning pins are not pounded into the hole, which we do when we string pianos or rebuilders do. They're actually turned so that the fine threads of the tuning pin are threading into the wood. And the pressure is absolutely vertical, turning that pin into the hole. So, and she said it ensures that the hole remains round. Now, think about if you're hitting the tuning pin with a sledgehammer, you're not going to be able to hit it absolutely directly at a perpendicular angle. There's going to be some side pressure one way or another, and it's going to vary from one pin to the next. I think that accounts for the inconsistency in the feel of tuning pins that we find in many pianos. Now, most factories use those machines like we saw in the Fazioli to insert pins. So they don't have the problem with tuning pins being pounded. But I think that video shows us some of the factors that account for the absolute consistency of the tuning pins in the Fazioli piano and the measures that rebuilders would have to take in order to get the same result. Of course, an individual rebuilder can't afford a several $100,000 machine to insert the tuning pins, but it's something to be aware of and seek a solution for.
I wonder if it's worth watching it one more time, just because you explained some things to look at and listen for after the fact that people might have missed. Let me bring it up and we'll watch it one more time. Did you want to throw another video? Yeah, we'll just watch that. Just a sec.
Okay.
The machine first drills the pin block before inserting the tuning pins to which the strings will be attached. The machine slowly inserts the tuning pin into the pin block. This is done with great pressure and precision in order to ensure the holes remain perfectly round.
Another comment I'd like to make in regard to that, when she's talked about making sure the holes remain perfectly round, That's one factor that can affect the feel or the consistency of the pins, but another is the tuning pins themselves. Now, I know a lot of rebuilders like to measure tuning pins before they install them. They'll use a micrometer and they'll grade them according to size, because there is a variation in the size and shape of tuning pins when you get them from the manufacturer. To get absolute precision in manufacturing costs more than most manufacturers are willing or able to do. So when you buy a box of brand new tuning pins, if you were to mic them with a micrometer, you will find that there's a difference in size of between 1 and 3/1000ths of an inch. That's the tolerance that they allow for, and that their machines are not capable of producing accuracy and consistency in every pin. Now, when you install those pins in a wooden pin block, the difference in size of the tuning pins is going to be felt. It's going to result in a different torque on the pin and a different feel of consistency. And if you want to overcome that, you'd have to get tuning pins made to a higher tolerance. And in fact, I believe Yamaha does that. I believe Yamaha makes their own tuning pins in their factory. They don't buy them from some other maker. I recently bought a set of Yamaha tuning pins and I measured them with my micrometer, and every one of them was within 1/1000th of an inch of the same size. So they were much more accurately made than the tuning pins of other makers. And that accounts for the better fit and feel of tuning pins on Yamaha pianos. So it's attention to minute details like that that make the difference.
As is often the case, the minute details are really what make the difference.
Yes.
Yeah, so did you want to go to a different video now, or?
Yeah, I have a few more videos that I think are relevant and will be enlightening. If you could run,
yeah, what's the next one?
Run video number 8 next.
Number 8. Before we roll number 8, I'll just give my opinion that I think it was the guy's green jacket and very serious look that was at play there. I think that was affecting the tuning pin tightness in that particular video. Just my opinion.
No, I think it was the British accent of the lady narrating it.
Could have been. Yeah, maybe that was it. All right, let's go to video number 8. Okay. Let's see here. 8. Okay.
So let's take a look at the structure of pin blocks and try and understand that better. I have here 2 chunks of sample pin block. They both come from Yamaha, and you can see they're quite different. One has equal sized thin laminations, about 1/8 of an inch each, and about 17 laminations of wood. Another one has 3 large laminations in the center, and then top and bottom, some very thin, like 1/64 of an inch laminations, 7 or 8 of them on the top and the bottom. Why do they do it 2 different ways? We don't know. That's a manufacturer's decision. And how does that affect us from the standpoint of being a technician or tuner?
Okay, Ethan, could you show the next one, number 9, please?
Well, I think that the thickness of laminations and the number of laminations does have an effect on the tunability of the piano. So if I put a tuning hammer on a pin in this sample pin block and I try and turn it, it turns fairly easily. I would estimate it's got a tuning pin torque of somewhere between 50 and 75 inch-pounds. Then if I go over to this other sample block that has different sized laminations with lots of very thin ones at the top and bottom, and if I try to turn one of those tuning pins, there's a lot more resistance. I estimate a torque on these of close to 100 inch-pounds. Now, it's pretty well known that when you have a lot of thin laminations like this, there's a glue joint between each lamination. So there's a lot more glue that this pin has to go through as it passes through the block, and that those layers of glue, thin as they are, but many of them, can contribute to a very tight tuning pin, and also to one that doesn't rotate uniformly, that doesn't feel consistent from pin to pin, and has a little bit of a kind of a slip stick movement as you try to turn it. And if you've tuned pianos with that type of pin block, you'll know what I'm talking about.
Okay, and could you show number 10 also, please, Ethan?
So here's some more sample pieces of pin block. These are both made by the same maker, and they're different, as you can see, different number and thickness of laminations, different height of the pin block. And I presume that this maker does it that way for different customer requests. But again, it shows there's no uniformity in how pin blocks are made, and it seems to imply that nobody really knows for sure what is the best way to construct a pin block, so they do a lot of experimentation.
So yeah, if I can make some comments about that. The use of a wooden pin block is inherently variable, reliable, inconsistent. Wood itself, you know, it's a natural material, and we run into problems with it all over pianos, which are made almost entirely of wood. Wood is so prone to absorb and release moisture in response to the climate that it's in, and then wood can warp and crack and split. There are just so many things, so many variables. And trying to drill a hole in a piece of wood that's accurate and consistent is an extremely difficult thing to do. And I learned this firsthand myself when I started doing touch weight design, and I wanted to change the line of capstans on piano keys. Following David Stanwood's protocol, I would remove the old capstans, fill the holes with wood epoxy or with wooden dowels, and then draw a line for a new capstan line where I wanted to install the capstans to get a better leverage ratio on the keys. And taking the most accurate precautions that I possibly could, I found it extremely difficult and sometimes impossible to drill holes that were all in a perfectly straight line. And I would examine pianos from factories and look at the original capstan lines. These were done in factories with supposedly all the most sophisticated, up-to-date equipment. And I saw the same thing. You can do it yourself. take a look at capstan lines on pianos, put a long straight edge up against them, and you will see many deviations from the straight line. And it's not from, I learned that it's not from carelessness or shoddy equipment. It's just, it's extremely hard to do because of the nature of wood, you know, the variations in grain. Wood doesn't have the same density in every spot like other materials like metal and ceramic and whatever else. There are so many variables in a piece of wood that it's impossible to get absolutely accurate and consistent results with such a simple thing as drilling a hole in a piece of wood. And that's why I'm advocating for and believe that we should get rid of wooden pin blocks in pianos. They make it really difficult to tune them, and they make manufacturers liable for warranty claims. And the history that I studied and learned shows that there have been many successful systems of pianos with all metal tuning systems. We don't need to use wooden pin blocks anymore. So I'd like to see if anyone has any questions or comments.
I have a question, Larry.
Sure, Carl.
So first of all, on the Yamaha pin blocks that you showed, what vintage are each of those, and what is the current Yamaha pin block look like?
Great question, Carl. Great question. I got these samples from a fellow technician in my chapter, Peter Wolford, and he passed away in 2005. I know he went to the Yamaha factory in about 1972. So these could date from that period, probably did 1972-ish. And now, as far as the current production, I have something to address that too. If Ethan would show my video numbers 5, 6, and 7.
Okay, one moment.
So what is this pin block in the piano that we're talking about and we hear so much about? I never even saw a pin block until I'd been tuning pianos for 25 years or so, because I never did rebuilding. And that may be true for some of you. You know what it is, you know where it is, but you never see it. Well, we know the pin block is what the tuning pins go into. And it's hidden underneath the cast iron plate, which is here to bear the 20 tons of tension of the strings. But we know that each one of these tuning pins is driven into a hole in the pin block, hidden underneath the plate. So if I could magically remove the pin block from this piano, here is what it would look like. It's a long plank of wood that goes across the entire width of the piano. You can see all the tuning pin holes in it, and there are also screw holes where it's screwed down into the rim of the piano. And this is actually a very highly engineered piece of wood. It's laminated. It can have anywhere from 5 to 25 different laminations of wood. And that's determined by the maker. It's their choice, their decision about what's the best way to do it. Laminated wood is much more stable than a solid block of wood can be. A single block of wood is very prone to warpage when it gets exposed to moisture and changes in humidity and temperature, the laminated pin block is a very stable piece of wood. So what is the difficulty with these wooden pin blocks? Well, you want to drill a hole that's the perfect size for a tuning pin of a particular size so that the tuning pin fits tight enough that it's going to remain tight over many, many decades, but not so tight that it becomes very difficult to tune it. So that's kind of a small window of what is the proper tuning pin torque to work for both of those purposes. And then there's many different problems that can intervene when you're drilling holes in wood. The size of the drill bit is important, of course. You have to pick the right size drill bit to match the size of the tuning pin. But drill bits heat up as you're drilling in wood. So, and when they heat up, they can burn the wood, and that can affect the tightness of the pin or the feel of the pin. If the wood is singed during the drilling, when you try to rotate that pin in the wood, it's going to feel, it's going to have a slip stick quality to it. Other things that can interfere are the size of tuning pins are not all perfectly uniform. They can vary by as much as 3/1000ths of an inch. And believe it or not, that's a very big amount, and it makes a huge difference in the feel of the tuning pin.
So, Carl,
Yeah.
the reason I wanted to show those was that that pin block that I was showing came out of a Yamaha Consagrand that was manufactured in 1998. And it was very similar to this sample that I showed, except I think there were fewer laminations, thin laminations at the top and the bottom. They were a little thicker and fewer than what I have here.
And what about the feel of it? Does it feel too tight to you?
On this sample, it does, yes. It's got a torque of about...
No, I mean in the piano.
In the
The
piano.
1998 piano.
Well, unfortunately, that piano had been restrung. So I don't know what it was like when it was original from the factory.
So an observation. I too work on a new Fazioli 278, which is the best piano I ever work on. It's what a joy to tune it.
Yeah.
Second of all, Yamahas I find unbelievably consistent and good. Rebuilt Yamahas are never good. I work on many that have been restrung, and the feel is never right. It's sort of spongy. So whatever they're doing in the factory is phenomenal. And when it gets out in the field and people do whatever they do, it's never as good.
I'm not surprised. I think there are some secrets in those factories, Yamaha and Fazioli, that we don't know, that account for the amazing consistency and smoothness. And I would love to find out what those processes are. But if we can ever get manufacturers to abandon wooden pin blocks, none of that will be a problem anymore. It will become moot. And these...
Why do they have to? I mean, like, for instance, the Japanese pianos. I mean, I work on a lot of Yamahas, Kawais, Steinways. I don't have any problem with the wood pin blocks. I think they're all, I don't see that it's a problem that needs to be fixed. They feel great to me. I'm not working on crappy pianos anymore, so I'm never working on Chinese pianos or anything like that. But I mean, on the good pianos, is there really a problem with wood pin blocks?
I don't have the same experience as you, Carl. At the concert hall where I work, I have a brand new Steinway D from New York and a new Steinway D from Hamburg. Those are among the toughest pianos I've ever had to tune. The tuning
Wow.
pins are way too tight to have a reasonable control over them. I've got all this snapping and
Wow.
I wind up overshooting the mark every time I try to tune. I cannot move the tuning pin and find little increments. And I've used many different types of tuning hammers on them too. So that wouldn't account for it. And I've measured the torque on them and it's ridiculously high.
Wow.
It's a problem that has bedeviled me my whole career with many pianos, and many other technicians I talk to agree with me about that. Maybe you just have really strong arms and lots of control.
Well, I don't think I have any special. I mean, I kind of adapt to the feel. I'm like everyone. I've tuned so many thousand pianos. I immediately kind of get the feel and adapt to each piano. But I'm really, and I do some Steinway new, both Hamburg and New York Steinway C&A pianos. Not a lot of them, but some of them. And I haven't had the experience that you've had. They tune well to me. I work on a lot of new and fairly new Yamahas and Kawais, and they're like a dream to me. So I'm not experiencing this problem.
Yeah, one of the things Larry went through in his master class was, what potentially the incentives are for the manufacturers around this kind of thing, right? Because they don't have to tune them so much as manufacture them. So there was some kind of, there's some potentially warranty issues they're trying to avoid. They're not as concerned with making it too tight because that helps with, keeping up a warranty versus, okay, so it's a little bit tougher to get it in tune, or, the tuning pins are a little jumpier, it takes somebody a little bit longer to do it. That might not be something they're as aware of, or is not on the top of their priority list. That's interesting. It's interesting. I think, Michael Spreeman's jumping in here. Just let him in. But yeah, I think that from what Larry's saying, it's interesting because I agree with you, Carl. Just I think as a person, I'm very adaptable. So I tend to be like, oh, this is what I'm dealing with today. I'm going to make it work. But it is interesting if you think about it and you look at maybe some of the trends that Larry is pointing out, that the tuning pins may be getting unnecessarily tight, and the manufacturers don't. It's just not on their radar, and that it's just not something they're concerned about. So, yeah, there could be room for that.
If I may, is it all right to speak, Ethan?
Yeah, go for it.
I have had the privilege of working with Chickering grand piano, without a pin block. And the interesting thing was it had tapered tuning pins with a little wedge at the bottom to lock it into place, so to say. And so one could tap down that pin to make the tuning pin tighter, or tap it from the bottom up a little bit to make it a little looser, and then adjust that wedge in a slot in the bottom of the tuning pin accordingly and keep it that way. What struck me was also the evenness of the tuning pin turning, but even more so, it had a much better tone to my ear than most pianos with wooden pin blocks. And what that tells me is that when the tuning pin sits more solidly in the steel than it can sit in any kind of wooden block, we have a stronger, more solid termination for the string, even though it's a few bearing points removed from the if that is an advantage, that may be another reason to push for pianos without wooden pin blocks, the better tone. And the most striking thing is, I've been tuning for 50 years. That piano only needs tuning every 10 years. You think that may put us out of business? No. The tunings are so good that word goes around. So that's my little contribution. Thank you.
So I just want to, just in case there's something to be said, and we've got about 15 minutes here or less left. I see that Michael Spreeman jumped on. I don't know if he's been listening online on Facebook and YouTube. But Michael, if you do have anything to say, I don't know if you have the context here or if you're just jumping in because of the topic, but you certainly do design and manufacture pianos. So you may have some interesting thoughts on this. Do you do you have any context here, Michael, on what we've been talking about so far? Or are you just jumping in?
Unfortunately, I just came in at the last minute, so sorry about that.
Do you mind if we pick your brain, or are you not prepared?
As far as what Mr. Krebs was speaking about the Chickering, you know, it's kind of a quantum leap to say that the piano has a much better tonality or it sounds so much better because of the pin block. I mean, there's so many other factors involved in the design of that piano that it would, you know, that it's kind of a blanket statement. I'm not saying it's not true. I'm just saying that, you know, from an analytical perspective, one would really want to, you know, have a look at everything else that's going on in that particular Chickering. You know, we're actually redesigning both of our pianos right now, and I've put together what I call a dream team. I've got Nick Ravagna, and I think a lot of you guys remember Leo from Germany, and then I've got a young guy doing a lot of CAD work. But we're right now talking about this whole topic of pin blocks and you know, whether, like a lot of the European pianos, the stretcher rail, for example, is not connected to the pin block, and the pin block is not glued into the shoulders of the inner rim, so that if it's necessary to make a repair to the soundboard or the bridges, you can literally loosen the tension of the strings and remove the plate, and the pin block comes with it. You don't have to unstring the piano. On the other hand, there appear to be some advantages to, like, the older Baldwin and the Steinway systems, where the pin block is indeed glued to the stretcher and glued in. You know, Steinway talks about this kind of ring of energy that happens between the radiating vibrations of the soundboard going into the rim and carrying through the case and that kind of thing. So it was a timely discussion for me to hear what you guys have to say. So I'll have to at some point go back in and listen to the recording. So.
Yeah, we're on Facebook and YouTube right now, so it'll be up for public viewing as well if people want to check out the recording here. But just one question, which is kind of the central thesis of what Larry was talking about. I'm curious of your opinion. Do you think that tuning pins have been getting tighter from the manufacturer over the past several decades? That's just a thing that's been happening. The manufacturer just makes them tighter, ships them out that way. Is there a pattern you've seen or are aware of?
I can't really say that I've seen a pattern. And, you know, unfortunately, for about the last decade, almost 2 decades, I've been so involved with my projects that I don't see a lot of new pianos coming out of the factory. I mean, I've broken 2 tuning hammers on the older Baldwin Grands, you know, where you have to put your foot up on the stretcher, and the pop and snap era. So, you know, obviously too tight is not good. It's interesting to me in my travels to Europe and in the few pianos that I've seen, and even when I worked with Rick Baldison up in Utah, where he had several European lines, my impression is that the European manufacturers tend to have a little bit, I hate to use the word looser, but, you know, their tuning pin torque specifications, I think, are lower than what some of the United States manufacturers are. And in talking to people like Leo and some of the BDK guys, their claim is that it's easier to get really fine adjustments and fine tunings. Now, I saw somebody placed a comment in the chat about the Steinway 1098s, and, you know, we all know what a bear it is to get those pianos into tune. And I think there was a while where I actually was doing a lot of service work and would refuse to tune them. But at the end of the day, when you get them in tune, you know, kind of like what the guy was saying about the Chickering, they stay in tune, you know, but it's just a major pain to get them there. Anyway, to speak to your question, I can't really say that I've seen a trend, at least in the American manufacturing, towards increasing torque. You know, I think it's been fairly standard. But then you have again, like the Baldwins, the different manufacturers that had, probably different standards than some of the other factories. And then there's just the whole, quality control thing where it isn't always exactly what they wanted their spec to be anyway. So
what do you have a number that you aim for in terms of tuning pin torque?
Off the top of my head now, I say that I've been using Bolduc pin blocks, and I would say to most people's probably impression, they're a little bit on the tight side, but I like to do that because, a good quality piano is going to last a long time, and the pin blocks will get a little bit, the torque will get lower, as the piano, especially in concert pianos. I'm seeing more and more, where a piano gets tuned 2 or 3 times a week. That's kind of brutal on the pin blocks. So if they start out a little bit I don't like them to snap and pop at all, but just prior to that is kind of nice for a new piano. So
yeah, check. You might check out Larry's masterclass content as well. He was sharing some graphs that he found of like how the torque will change over time, after like 500 tunings or something like that. It was interesting that it seemed to at least level off, right? There's like kind of like a curve that kind of levels off after a bit. And so that you can kind of guarantee it's going to settle into at a certain torque by a while. It's not just going to keep going down in a linear fashion or something like that.
Yeah, I very much look forward to listening to this whole discussion.
Cool. Well, thanks for popping in. Sorry to put you on the spot.
Absolutely. Yeah, no worries. Sorry to come in so late.
No problem.
Can I just jump in as long as we have Michael here?
Sure. We got about 5 minutes left, by the way, but yeah, go ahead.
Okay. Well, Michael, you're just the type of innovator and experimenter that I'm aiming my talk at. And the fact that you said you're particularly focusing on pin blocks right now gets me very excited. And I would love to share with you the research that I've done. And I've discovered that in the late 19th and early 20th century, there were many companies that experimented with pin blocks made entirely of metal or an all metal tuning system. And they weren't all just experiments. Some of them were put into production, remained in production successfully for decades. And I think hardly anyone today is aware of that. And I think you might want to take a look at that, and I'd be happy to provide the information I found to you.
Well, thank you, Larry. Yeah, I would absolutely be interested in talking some more with you about this. Maybe we can connect, privately after this. When I started, I actually started the Ravenscroft business in 2004, and Harold Conklin was still alive at the time. And because of my mentor, Jim Coleman Sr., he knew him. I reached out to Harold because the first piano that I had to modify was a Baldwin. It was actually an SD11. It was a prototype that they had that they sold me. And I had some questions. So I was able to track down Harold, and he was telling me that he had some patents pending for a new pin block design that did not involve wood. And he was going to send it to me, but I never received it. But I know that there have been a lot of very innovative approaches to a non-wood, long-lasting pin block. And most of the manufacturers can't do it because it's cost prohibitive, because of the time factor and the engineering and things. So I think that's probably why they never came mainstream. But yeah, I'm definitely interested in that, and I'll contact you, Larry, when we get off the meeting, and maybe we can hook up and discuss this.
That sounds great, Michael. I would love to do that.
Cool. Well, yeah, that sounds wonderful. We have just a couple of minutes left here, so I definitely should sign us off soon. But glad for everybody jumping in and getting part of the conversation, and glad for Larry to stimulate the conversation. I think I put some trust in Larry to say, let's talk about tuning pins for 2 hours, because that's what he thought was interesting. I said, all right, let's go ahead. Let's see how this is going. I don't think it was easy to sell it beforehand, but I think seeing this kind of discussion maybe will spark people's interest, and they'll kind of get into the recording. So you can visit the same page to purchase the lecture recording as well. We'll have that available soon. I want to give Larry a chance to wrap up, for just a moment before I sign us off. But any final words for us, Larry?
Sure. First of all, I'd like to thank you, Ethan, for making this platform available to me where I could share my obsession with so many technicians. And I hope that it's going to lead to other people thinking about this problem and acting on it, talking to each other, talking to manufacturers and rebuilders. And I'd like to see some changes come about as a result of this. And that would be really thrilling.
Cool. Yeah, agreed. And final comment from me. I mean, I've always really enjoyed the way that Del Fondrick thinks about pianos. He reduces things to first principles. He's like, okay, so why do we have this thing here? What are the things it needs to do? And then let's build back from there and see if we come up with the same answer or something different. So I feel like there's definitely some room for that here, and I'm sure Michael's and the folks he's working with are great minds to be working on that. And by the way, the lecture I linked to, although the time ran out on the timer on the page for the price that we offered before the actual lecture, the price did not change yet because I actually have to do that manually. Give you a little bit of behind the scenes of what has to happen to make things work around here. So I think you should be able to still pick up the recording for the reduced price if you want to try to grab it soon. Next couple of hours or days, that price will be changed. So I think that'll be it for today. Again, a reminder for everybody to visit pianotechradiohour.com. I'll put the link in there. That's actually where we're hosting a page for our podcast. And this podcast features previous episodes of what we do here on the Zoom calls, polished and put together as podcast productions. So you can listen to the content while you're working in the workshop or driving from tuning to tuning. It should be pretty fun. We've already got some great reviews up on that if you check Apple, iTunes, and so forth. And but if you did want to check the videos, that'll always be in the member area and exclusive access for those that are subscribers to Radio Hour. So I'll give us a sign off here and then we'll hit the road. We've reached the end of another musical journey here at Piano Tech Radio Hour. Thanks to Larry and everyone else that contributed to the conversation today. As always, we're brought to you by Piano Technicians Masterclasses, cutting edge instruction from piano industry masters without leaving your home. And for those of you that joined us by signing up for this session individually, you can make your life more convenient by subscribing to PTRH at just $16 a month. So you get the recording of today's session in our member area, as well as automatic registration for each week's new session. Sign up at pianotechniciansmasterclass.com/PTRH-direct access. We put the link in the chat so it's not hard to find. And that's about it for today. We'll see you all next week. I did get some feedback that maybe there's some glitch with signing up for Radio Hour, so I'll look into that. But yep, everything was wonderful today. I appreciate all the time and energy.
Thank you, Larry.
Thanks, Carl. Thank everybody.
Awesome.
Nice to see you all.
Bye-bye.